The unit circle. Well, we've already divided the unit circle into halves and into quarters. Now we're going to divide the unit circle into thirds. So really we're dividing the whole circle into sixths, but if we take all the way over to pi, we're dividing pi into 3 sections. So we have 1 pi over over 3, 2 pi's over 3, 3 pi's over 3. And if we continue, 4 pi over 3, 5 pi over 3, notice we skip right over the y-axis. And then all the way up to 6 pi over 3, which we know of as 2 pi. So this is actually part of my third right here, the x-axis. My y-axis is not part of that third. We could continue because of our wrapping function. If we're looking in terms of radians, if we continue with this distance, 6 pi over 3, continue wrapping 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, or 4 pi. So remember, our wrapping function takes a radian measure, how far we've gone around that, and it gives us a point. Now we don't know yet what this point represents. We know this is 1, 0, and we know that this is 0, 1, but we don't know our pi thirds point yet. But we can talk about it in terms of a wrapping function in what it's equivalent to. So if we take the wrapping function of pi over 3, we don't know the point yet, that's what we want, but we also know that it's equivalent if we wrap pi over 3 plus 2 pi. Now let's talk about why that is. So when we wrap a function, if we have just pi over 3, we wrap to here. All the way around the circle is 2 pi. No matter where you start from on the circle, if you go all the way around a full circle, that's 2 pi. So if I take pi thirds and I add 2 pi, I'm right back at the same point I started. Same is true over here. If I have 2 pi over 3 and I add 2 pi to it, I go all the way around the circle and I'm right back where I started. So I can take this and I can make equivalent wrapping functions. Now, pi over 3 plus 2 pi, in general, if we added those two, is not the same as pi over 3, but when we're wrapping, we're coming back to that same point. So the wrapping function of pi over 3 is equal to the wrapping function where we're going to end up on that point of pi over 3 plus 2 pi. Now, in order to make that an easy calculation, I change 2 pi to thirds, so 6 pi over 3. So I have pi over 3 plus 6 pi over 3, which is wrapping function of pi over 3 is equal to the wrapping function of 7 pi over 3. I'm going to end up at the same point. Now I can also take 7 pi over 3 and find another equivalent amount of radians. It's going to give me the same point. So I can add another 2 pi to it. And I can keep on doing this. So I have 7 pi over 3 plus 6 pi over 3. That's 13 pi over 3. So if I were to wrap 13 pi over 3, I would end up right back here at pi over 3. I can also find a negative value that will give me that same pi over 3 value. I can subtract 2 pi. If I subtract 2 pi, that just means I go in the opposite direction all the way around the circle, and I end up right back here where I started. So the wrapping function of pi over 3 is equal to the wrapping function of pi over 3 minus 2 pi. And I change it to thirds. So pi over 3 minus 6 pi over 3, which is the same as 2 pi, is equal to, this should be a negative right here, negative 5 pi over 3. So we can even check it on this one. We can go negative 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, negative 5 pi over 3. And I could make another negative if I wanted to. I could subtract 2 pi again from 5 pi over 3 and end right back up there. So now let's look at where this wrapping function, what point it actually maps to. And we're going to go about it in the same sort of way that we calculated where the point was for pi over 4. We're going to make and construct a reference triangle. So here, this point right here, pi over 3, I know it's 1/3 of the way to pi. So 1/2 of a circle is 180 degrees. If I cut 180 degrees into 3 slices, I know that this angle right here is going to be 60 degrees. 180 divided by 3 is 60 degrees. So this is a 60-degree triangle. I constructed it so this was 90. So this angle right here must be 30 degrees, and it's a special right triangle. This, my hypotenuse, I know has to be 1 because it's a unit circle. So take the radius and turn it all the way up. So my radius is 1 right here. Now when I know my hypotenuse, I can construct the rest of my values. I know my small side, my short side across from the 30, is going to be half of the hypotenuse, so that when I double this, I get the hypotenuse. Then I take the short side multiplied by rad 3 to get my long side right here, or rad 3 over 2. So now I have my distance on this point, my x distance, and my y distance. My x distance is 1/2. My y distance is rad 3 over 2. That's how far I've gone up. So not quite to 1 up there. And so this is my distance. Now if I take this triangle and I flip it over here, you'll see that my distances are going to be the same. The only change is now my x values, which were positive over here, are negative over here. My y values haven't changed. So that's how I get the negative 1/2 comma rad 3 over 2 for this, for 2 pi over 3 radians. So when I put 2 pi over 3 radians in my wrapping function, this is the point it will be on the circle. So that's the coordinate point. And I can do the same thing down here. I can construct that exact same triangle, but my difference is going to be whether things are positive or negative. So in the first quadrant, we know both x and y are positive. The second quadrant, we know that x is negative and y is positive. The third quadrant, x is negative and y is negative. And the fourth quadrant, x is positive and y is negative. So now I have my values for my thirds of my unit circle. So now we're going to go ahead and see how the wrapping function works with this. So if we want the wrapping function of 5 pi over 3 radians, we take 5 pi over 3 and wrap it around the circle, and we want to know what point it comes to. Well, we go all the way around here. Here's 2 pi over 3, 3 pi over 3, which is just the same as pi, 4 pi over 3, and 5 pi over 3. So the point on the circle when I wrap 5 pi over 3 radians around is 1/2 comma negative rad 3 over 2. Now let's take a look at this one. We notice that we have 10 pi over 3, and that's more than 2 pi. So we're going to have to continue wrapping. Now if it's a kind of small number, you can just keep on wrapping. I mean, you can look at the circle and figure it out. I go all the way around. I have 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3. So I'm going to be right here. But you may want to also use what we know about if you go around the circle, it being the same. So we can take 10 pi over 3 and we can subtract 2 pi. We're going to end up in the same place if we go around the circle a full time. We're going to end up at the same place. So if we subtract 2 pi, we get 4 pi over 3, which is exactly what we got when we counted. And if we had to again, we could subtract another 6 pi over 3 or 2 pi, and we would end up in the same place. Now this is not to say that in general the length of 4 pi over 3 is equal to 10 pi over 3. It's only if we wrap it around that circle. Okay, so say we have negative 7 pi over 3, and that's more than 2 pi in the opposite direction. But we know it's just one more, so we could actually wrap it in that direction once, and then one more pi over 3, and we know we'll end up here. So we could do it visually. But we could also know that we're going to end up in the same place if we add 2 pi. So we did that over here. So I have negative 7 pi over 3 plus 6 pi over 3, which is 2 pi, so once around the circle, and that's equal to negative pi over 3. So then I could look at this and go negative pi over 3. Now if I don't like the negatives, I can even add another 2 pi to it, and I'm going to end up in the same place. So negative pi over 3 plus 6 pi over 3 is just 5 pi over 3. So I can wrap it 5 pi over 3, and that will be exactly the same as negative pi over 3. So I'm going to end up at this point every time, whether I do it just with the unit circle, just actually following all of the pi's over 3. If I add 2 pi over 3 and then do that negative pi over 3, or if I add another 2 pi over 3 and end up here at 5 pi over 3, my point I'm going to get out is 1/2 comma negative rad 3 over 2.